side distance, it is the length of road visible ahead of the driver at any instant. Visible ahead of driver at any instant. Restrictions to side distance are at a horizontal curve, driver moving in this lane should have a visibility of the vehicle coming from the opposite direction here. That is, this is the side distance, the stopping side distance or side distance, and this is side triangle. Sorry, this is sight line. Sight line. So there should not be any obstruction beyond this sight line. That is, obstruction should be in this side, not inside the sight line. If it is in that line, then side distance cannot be maintained. So this is obstructions to vision. The horizontal curve, there will be a problem of sighting distance. Similarly, in case of vertical curve, for the car traveling here, due to the vertical summit, the obstruction here, should be 1.15 meters or higher than that. This is sight line, and this is eye level of the driver, which is 1.2 meters. Then this will be the stopping side distance. So on vertical curves, there will be a problem of side distance. Next, in case of intersections, especially at an uncontrolled intersection, driver coming in this lane should have a visibility of the driver coming from this lane. So this will be side distance, and this also will be side distance, and a side triangle is formed here. This is sight line, obstructions to vision. This is side triangle at intersection. Coming to stopping side distance, it is sum of lag distance plus braking distance. Lag distance is the distance traveled by the driver in the reaction time, that is velocity or speed into t, and braking distance, we will derive that now. We know that kinetic energy is half mv square, that is wv square by 2g, and friction on the vehicle will act in the opposite direction this is a normal reaction which is equal to W, then the friction force is F into W. The friction force is F into W, equating kinetic energy to work done. Kinetic energy is equal to work done. Kinetic energy is WV square by 2G. Work done is force into displacement. Force is frictional force into displacement is L length. Say this is this is braking distance L. This is SB. So braking distance will be WW get cancelled V square by 2GF. So the stopping side distance on a plane road is Vt plus V square by 2GF. And these are the recommended values given by IRC 73 for stopping side distance corresponding to different speeds and coefficient of friction. And next is given that V1 vehicle is approaching with 90 kmph, that is 25 meter per second, and a vehicle V2 with 60 kmph coming in the opposite direction, that is 16.67 meter per second. So this is first vehicle traveling with V1 velocity or speed and V2. So the safe stopping side distance will be sum of stopping side distance required for first vehicle plus stopping side distance required for second vehicle. First vehicle stopping side distance is Vt plus V square by 2GF. V is 25 into T is 2.5 seconds plus V is 25 square by 2 into 9.81 into F is given as 0.35 plus for second vehicle it is 16.67 into 2.5 seconds plus 16.67 whole square by 2 into 9.81 into 0.35. First vehicle stopping side distance is 153.515. For second vehicle it is 82.142. So the sum is 236 meters.